first question is like, why do we want to decentralize AI? What are the unique things that decentralizing provides? And maybe let's do the introductions kind of after. Let's do a quick round of like why, and then we can talk about like how your projects like make that happen. But David, maybe starting with you, why do we need to, why must we decentralize AI?
Yeah, thanks for the invitation and the excellent prompt. I'm David from Lit Protocol. Get into some of those details later. But in terms of the why, I think we can look back at what happened with Web 2 and social media. I think a lot of people in this room probably have a pretty clear picture that the Web 2 social media walled gardens, not because they necessarily had malicious intent, but based on the incentives that structured those systems, is there's been a real fracture in society in terms of like epistemology or truth-seeking based on the fact that all of these platforms are motivated to keep people's eyeballs on the page. And when we kind of are nearing AGI over the next couple of years and then beyond that, if we don't look at this from the perspective of data, and I'll get more into that, but that's generally the lens that we're looking through, is the data, the inputs, the outputs as it relates to the AI and how this can be managed in a private way. For me, there's like a real existential fear that what seems troublesome now in terms of societal division and lack of agreement on truth just will spiral even further out of control without the infrastructure that is kind of being collectively worked on here.
Cool. Anil, maybe over to you, and so that's kind of like the doomsday societal impact will be a dark alley that we've kind of walked into with Web 2. Let's back out of that and walk towards a brighter future. What are some of the other reasons, maybe taking another lens, like an economic lens, or whatever lens you prefer, on why we should or must decentralize AI?
Yeah, I'm going to try to take a more positive spin on this. So if you look back in history and you think about sort of the biggest technological innovations that have propelled humanity forward, what are like the top 2 or 3 that you can think of? The very first one is probably the PC revolution. The second one is probably the internet revolution. And then the third is mobile phones. These are things that pretty much all of us use on a day-to-day basis, right? And then if you were to think about probably the one that has impacted people the most out of those 3 is probably the internet, because it connects mobile phones and PCs together, right? And people together, more importantly. And so if you think from the internet era till now, there's probably not been another technology besides AI that's potentially going to promise or deliver a significant amount of improvement to humanity like the internet has done. And so if you agree that AI is sort of on the same level in terms of its impact as the internet, and then you think about what the internet would look like if it was closed and if it was controlled by just a handful of players, that would be a very different scenario in terms of innovation, in terms of people being able to create economic value relative to what it is now, which is with an open internet and an open way to communicate. So I think from that perspective, even though we might have a few closed systems for AI, I think there's definitely going to be sort of a vast majority of AI is going to be open, and that's going to lead to a significant amount of innovation, which ultimately is going to improve humanity for the better.
Cool. And then over to you, Harry. Like maybe talk a little bit about why we need to decentralize AI in the context of like what's uniquely possible with decentralizing AI.
Sure. So glad to be here. Harry Grieve, co-founder of Gensyn. There's really 3 reasons, in my opinion. So the first is price. By disintermediating cloud providers, you're able to achieve a much kind of smaller unit economic cost for accessing, say, an A100 or time on an A100. Point 2 is scale. You're physically bound by the properties of a data center, for example. When you want to train a model in a centralized context, models are going to break out of the data centers eventually. We see early signs of that with Google DeepMind's work with research like DeLoco or DePaco, where we train between multiple GCP sites. Of course, doing that in a decentralized network allows you to leverage all the compute. And thirdly, it's progress. In the kind of medium term, lots of opportunity exists for machine intelligence to exist on-chain, to have its own cryptographic property rights, to train itself and create value, not just for humans, but for other machines too. An entire parallel economy could exist, but only if that economy is kind of given a substrate that it can grow on, which isn't centralized. So in summary, price, scale, and progress.
Awesome. I love that because it's very specific and we can actually click through each of those. And I hear you too also on kind of like the societal need for it to happen. But I think I am kind of with you in that like if we actually want to catalyze the transition, we need to be able to compete with the cloud, and you compete by having a cheaper product, a better product, and a product that is an innovation engine that can like iterate faster and get to better results in a quicker time frame. Let's click into each of those, right? So like, how is decentralization helping us? And maybe comment on that, and maybe weave in some of the work that you're doing with Gensyn, with Akash, and with Lit, right? Like, how are you driving down cost?
Sure. So Gensyn is a machine learning compute protocol. It enables a machine learning engineer or researcher to submit a computational graph. So basically a PyTorch training run, for example. And for that graph to be split across multiple devices around the world, executed on those devices, the work's verified that it's been done correctly, and then the work's recombined into something that the user receives as a return. And then they pay for it. Ultimately, we hope in fiat as a kind of gateway to the service, but the chain's all dealt with a native token. When we think about the user, my co-founder and I, we come from the machine learning world, so we're not kind of crypto people by background, so we have pretty deep empathy with not just the kind of issues they have, but the kind of crypto skepticism that a lot of machine learning people feel when they think about crypto. They think about kind of, monkey pictures and, FTX and everything, and it's they need basically an incentive to move over. And we think of it as a kind of four-way optimization problem. They want a low price, they want high scale, they want at least the same performance that they can get in terms of time or model kind of, model strength. And then finally, they want something which is usable. It doesn't change their user experience. They want to be able to train models that they could otherwise train on AWS. A lot of the work we do sits around two areas. Working out how that UX doesn't change. So for us, that means that you should be able to train an arbitrary machine learning model. It shouldn't just be tightly locked to one type of model, because in that case, you dramatically reduce the kind of the surface area of customers that you can access. And secondly, the scale piece. It's quite easy to make blockchains work at low scale, but when you go high scale, you encounter verification problems. So we focus very, very deeply on how do we verify that the work's done, and we do that through a novel compiler stack, and also through our work to kind of game theoretically secure through partial replication work done on untrusted hardware. So in summary, Gensyn allows machine learning engineers to train large neural networks across heterogeneous, untrusted devices in a way which is high scale and low cost.
Cool. I like this idea, maybe let me paraphrase it, of sweeping crypto under the rug, right? Like you're still using the same, it feels the same, it feels familiar, you're just replacing the infrastructure on the back end. There is, and you talked about verification, making that possible, there is something that I want to call almost like a decentralization tax. Right, like there is a lot of savings that you're driving by providing infrastructure across a network of people who compete to provide their resources at the lowest price point. But there's also the flip side, right? Like you're also seeing, and I'm kind of wondering where that nets out. But can you talk a little bit about what's the decentralization tax? Like what are additional costs, the verification and these kinds of things?
So in the kind of marginal unit economics of it, there's kind of on the I guess the positive side in terms of what lowers the price, you're bringing in more devices into the fold, which typically has a deflationary effect on price. You're also disintermediating kind of central parties like GCP who charge up to 70% gross margin. So the price is going down due to the scale, and you're removing the margin piece. On the other side, however, you have two taxes. One of them is the decentralization tax, as you say, which is essentially how do you verify that the work's been done. We work very hard to minimize that verification overhead. A very kind of crude approach to doing verification would just be get 100 people to repeat the job and then compare the results, but then everything's 100 times more expensive. So how can you minimize that cost is one of the big bits of research we do. I'm happy to talk about that later. And the second piece is there a cost to actually training a model in a parallelized way? And this is one of the biggest kind of debate areas, I think, right now in the space. Basically, if you take a model outside a centralized cluster and you train it, is it more or less expensive? Conventional wisdom would say it's more expensive because you don't have the interlinks that, say, you get with NVLink, et cetera. It tends to be less optimized. However, it opens up this opportunity to train new types of models, which actually lean into the fact that it's high latency and it's kind of low bandwidth in exchange for getting much more compute. And we do a lot of research in that area to build new novel model architectures, which actually take advantage of a decentralization and turn it from a bug into a feature.
Yeah, I think one thing that I would add there is like you're also enabling composability and stitching together different things. So you're allowing people to, like you're describing on the verification side, really drive down efficiency.
Yep.
And then you're allowing folks like Lit, and maybe you can comment on that, to build things on top of that that make data access controls and things easier. So you actually have a whole ecosystem of people that are solving different parts of the problem, very different parts, right? Like fundamentally, like the infrastructure cost decrease, and then maybe interacting with that infrastructure in a way that limits access control. Let's talk a little bit about that. So I think we did a great deep dive on kind of the cost and what the opportunities and challenges are there. Thank you for that. Let's talk about this component of using Web3 as an innovation engine, right? Like, and not only to drive down costs, but then also really leveraging the strengths of composability. So maybe over to you and kind of talking about like what are the things that you unlock that you could stitch together with a very low cost-based infrastructure network of services.
Yeah, excellent prompt. I think just for a little bit of context, Lit Protocol is a distributed key management and blind execution network. It uses something called multi-party computation threshold secret schemes to manage keys in a distributed way, and something called AMD SEV SMP, which is a type of trusted execution environment that we have written a specific operating system for, because these secure processors are initially built for Web 2 cloud providers, which make the fundamental assumption that app owners should have all of the data. There's a different assumption in Web 3 about who should own the data, which is why we've gone through this work of sealing the TEE environment and making that available as a service. In terms of new types of products that are possible, one of the main ways that people use Lit Protocol today is encrypting data and storing it on the open web, systems like Arweave, IPFS, on blockchains, et cetera. And some of the early but kind of like bleeding edge experimentation that we've seen are things like community-owned AIs, where you could have a specific interest group. You could imagine a subreddit, for example, that has their data that's on the open web but private. It can't be freely crawled. And then that information can be decrypted in a secure hardware environment. It can be used for RAG or real-time training, or potentially as an input for inference there. And you can imagine this idea of taking an interest group like a subreddit and kind of collapsing it into an avatar, such that somebody can then have a conversation with that agent that represents 10,000, 100,000 people underneath. And then in the ideal world, we get to a level where the people that provided those inputs are also getting paid as a result of the economic benefit that the agent that is representative of that community in this like notion of decentralized collective AI would emerge. And certainly the same type of interoperability as it relates to user-owned data also applies to individuals as they interact with multiple platforms. We're obviously, of course, in the Web 2 construct in a world where the Web 2 platforms manage 100% of the data and don't give any of it back to the user. That's slowly but surely starting to change. And there's certainly a lot of enthusiasm in the user-owned data world that AI is the killer app for user-owned data. People have been playing and dancing with user-owned data for multiple decades. It really hasn't had its breakout moment that is starting to look more possible.
Cool, thank you for that. I would love to, Anil, maybe kick it over to you with the prompt changing a little bit, because now we're kind of hearing the first use cases described, and maybe the AI, obviously all the rage, right? Like that's what everyone's focused on, and there's a panel and people are excited about it. I'm curious, Anil, like what do you think are the first use cases that we will actually like see manifest, right? And feel free to also weave in what you're doing to make that happen, or what use cases you're excited about.
Sure.
And then maybe also talk a little bit about how you prioritize, how you think about what use cases should exist first.
Sure. Yeah, so a little bit about Akash for people that aren't familiar with us. We are the world's first super cloud, decentralized or centralized. We wrote our white paper way back in 2018, before DePIN was even a thing. and launched our mainnet in 2020. And we've been pretty much a full service cloud since then for people that want all sorts of workloads deployed, right? We have sort of focused on GPUs for more than a year now. Obviously, there's a lot of demand from there. And so specifically, we have compute, regular compute, accelerated compute in terms of GPUs today, in the future something else, and also storage, both ephemeral as well as persistent on the network. We've had a ton of applications deployed on Akash. A few years ago, it used to be everything from static websites to blockchain nodes and all of that. And then in the last 1 year, we have had a ton of interest from AI startups specifically looking to build inference applications, right? So the most common path that we see happening is AI startups, and many of these startups are actually non-crypto, non-Web3 startups. They typically want to validate some sort of idea that they have, and they want to be sort of first to market. So the typical pathway that we see is that they go and they start using OpenAI's APIs. So they are typically like GPT-3 APIs or GPT-4o APIs, and they validate that they can use them for inference and that there is an actual need for whatever the services that they're building. Once they do that, they quickly find out a couple of things. They find out that number one, the cost of continuing to scale on OpenAI's API is significantly high, right? Because OpenAI just charges significant amount of money for that. And then the second thing they find out is that there isn't a significant moat for them to continue building on top of OpenAI. And it's for two reasons. One is because OpenAI is a general purpose model. It's not a specific model that's fine-tuned on any sort of data. And then second is because, as you've seen with OpenAI, they periodically go and build functionality within OpenAI's platform itself, which puts a whole bunch of startups out of business, right? So what they find out is that they have a need to go and actually host an open source model, fine-tune it with their own data, and run it on their own sort of cloud, if you will, right? And that's where Akash comes in, and that's where they find out Akash really attractive, because now they can actually run these models. We're a completely open source cloud. All of our code is open source, and we're probably one of the best places to run open source models, right? And so they come to us, they run their models on Akash, and the other great benefit that they get is that if you go to Akash today, if you just go to akash.network and click on GPU pages over there, what you'll see is that you can rent like an H100 GPU, which is pretty much the highest end GPU that's available from NVIDIA today. You can rent it for $1.50 an hour from Akash on demand. If you compare and contrast that to something like AWS or GCP, you'd have to go there and probably get a contract for a year or 3 years, and then you'd probably be paying $3 or up for that same H100. So it's a significantly high cost barrier for these startups to get started. And so just to give you some examples of companies that have built on us, specifically talking about use cases, because you brought that up, Lukas. The first example I'll give you is a company called Brev.dev, Brev as in brevity, Brev.dev. They're a non-crypto company, and before they found out about Akash, they had launched essentially a platform that they call the pro tier for Google Colab. So Google Colab, if you're not familiar with it, is this service that lets you spin up a Jupyter notebook in the cloud. And Google basically was offering it as for free, but they would give you really low-end GPUs. So they would give you like a Tesla P40 or a T4 or 1080 Ti. And so researchers that were trying to use Google Colab liked the service, but they really needed more power. And so Brev.dev built a service where they wanted to offer higher end GPUs and build a much slicker service than what Google Colab is. So they got a lot of demand from users, but then the demand kind of plateaued because they were looking for higher end GPUs. So they went to AWS and GCP and they said, hey, would you give us some H100s or A180s? And the thing they came back with was, what's the size that you can commit to? And obviously this is a startup and they can't commit to like millions of dollars of GPUs. And that's where they kind of got stalled. And then Akash was kind of the solution to that, where they're integrated with Akash now. So if you go to brev.dev, sign up, you'll see actually Akash, you'll see GCP, you'll see AWS, you'll see like Lambda, a whole bunch of these. And Akash is significantly lower in price compared to the other ones. So that's one good example. Another good example now on the crypto and Web3 side is Venice.ai. This is a startup that was started by Eric Voorhees, who's one of the OGs in crypto. And they are actively using Akash right now. And so if you go to Venice.ai, they have basically an open, decentralized equivalent of ChatGPT, and that runs on Akash. And then the third example, which is sort of similar on the same vein as what Harry was talking about, is a company called Prime Intellect. And what they're building is basically a way to be able to do what's called heterogeneous training. So just to give you an idea of AI training in general, most AI training today happens in what are called homogeneous clusters. So if you look at, for example, ChatGPT's first version, which is GPT-3, it was trained on a homogeneous cluster of NVIDIA V100 GPUs, and then the later versions are trained on H100s, right? What's really going to accelerate or make people or make models more, open source models accelerate much faster than closed source models is if you can find a way to do training across GPUs of different types. So being able to train across a cluster of H100s, Z100s, 3090s, so on and so forth. And so there's been a paper written, and you can look it up. It's called DiLoco, and this is a paper that talks about how you can potentially do this. And so Prime Intellect, this team, is involved in building an open source version of that DiLoco paper, and that's something that they're going to be running on Akash as well.
Cool. Thank you. When I hear things like, oh, we're like the cheapest provider compared to GCP or something, I'm always like, how? Because I hear Harry's point on like, it does have scale benefits, but I also know that like, the Decentralized Cloud also has substantial scale benefits, and they do charge a 70% margin, but they're still operating pretty efficiently. So I'd love to, maybe if we have time at the end, to talk about how you're using block rewards to bootstrap a network like this and make these kinds of price points possible. Before we get there, I want to get to something that Tom mentioned, where he said something like, the demand is looking for enterprise-grade supply because there's just an expectation around reliability and things. And especially around inference, and Harry, you alluded to it earlier, you need a way to verify that whoever takes the workload and does the inference for you does their job properly. Could you briefly shed some light on how you're thinking about verifying all sorts of compute workloads? There's a deterministic way, a probabilistic way, and just kind of like discuss the challenges a little bit. I think it's worth putting in this form.
Yeah. So there's three schools of thought when it comes to verification. And firstly, we only do training. We don't do inference. But
yep.
for inference, there's the idea that actually you don't need to do verification, and it's kind of what you see is what you get. And for a lot of generic inference use cases, like language modeling, where you ask GPT, what's the population of Taiwan or something, and it gives you an answer, and if it looks about right, most people don't question it. So, there's that idea there where like what you see is what you get. For inference specifically, it's very hard to reason about the kind of, same problem for training, because you're looking at, a 7 billion dimension space, floating points where you're like, okay, well, I can't really reason if that's right or wrong. So that's point one. Point two is this idea of kind of having hard, deterministic sort of verification where, everything is, and the strongest example of that would be like zero knowledge cases where you put a model into a circuit and you train it. And then you get kind of proofs out which demonstrate that it's the model which has been, you asked to have been trained. That's highly expensive and prohibitive right now for most training stuff you can do.
Because you have to run the job twice at least.
You also just have to run it in the circuit itself, which just slows things down. You have to cast it into different data types. A lot of the time you can't even run it on a GPU. Like there's just lots of things which slow it down. And then the third type is the more probabilistic type, which maybe even includes some of the deterministic stuff, but only for like subsets of the process. And we kind of we're kind of in between the two, where our machine learning runtime enables deterministic execution across heterogeneous devices, like Anil mentioned, but we only check kind of portions of the work, and then so it is kind of optimistic or probabilistic in that you're only kind of checking a little bit, but it's game theoretically secured higher up. Kind of verification for training is super important. As I said before, you can't reason about just the parameter space being correct or not. It's also very difficult to kind of know, in many cases, like what the actual outcome of the training run you're doing should be. So if you're doing machine learning research, it doesn't follow that the result should actually be good.
Yep.
And I think this is lost on some people who only look at it in the kind of production, kind of machine learning engineering case. But if you're doing research, sometimes a bad result's actually instructive.
Yep.
So when you have these kind of alternative kind of approaches to verification, where instead of people executing a predefined job, a kind of fourth category would be you get given a kind of problem, like I have this diagnostic medical model, I want you to train it, and I want it to have like the highest accuracy possible. actually maybe for some people that isn't useful because they want to train it their way and they want the outcome to be whatever the outcome was going to be, and sometimes that outcome isn't good. So yeah, I think in summary, for inference, there's a kind of question about whether or not you do need verification. We're, like, as a kind of protocol, relatively unopinionated about that because we only focus on training. When it comes to training, the harder deterministic stuff tends to get quite cryptographic. The probabilistic stuff is the most kind of sensible when you go back to that kind of tetralemma of the 4 things which matter for users. But you kind of have to use a bit of both to make it optimal.
Yeah. It's almost unfortunate that AI is kind of the hottest compute workload that's out there, but it also seems semi-badly equipped to leverage all the strengths of crypto that come with verifiability. And right, like I wish the workload that was hot right now was really catering to the strengths of crypto, but here we are. I'm curious maybe, and let's close with that. What are some dead ends? Like when you're looking around the ecosystem and AI and DePIN and Web3, where do you think like a significant amount of resources are being invested, but you're kind of like, that feels like betting on the wrong horse, if anything? Anyone has a take on this?
Just across the board, any sort of applications
like
at all?
where you're seeing, because we've been on a few cycles before where there's hype, right? And AI is hype, and so I'm kind of like, are we falling into a similar trap? And what are the things that we should be dodging?
Got it. Yeah, I think I can take a stab at this. So, yeah, I agree that AI is definitely the hype today, and I think a lot of at least the hype for DePIN networks right now is being driven by pure scarcity of the compute for AI. Let's face it, it's not going to last forever, that's for sure. There's going to be, obviously, every time there is a huge amount of demand for something, there's going to be competition, and that's great. And so I think what's going to end up happening eventually is that there are going to be, like AMD, for example, is going to either by itself or through people like George Hortz, who's this famous hacker who does all sorts of hacking on at the hardware level. He's working on basically much better drivers than ROX CM is today for AMD, and that's going to potentially enable people to be able to use AMD to a comparable level as what NVIDIA is, and so that's going to alleviate some of these problems. And eventually it will plateau a little bit, right? So I think, but the cool thing about it, I think, is that as a result of all the focus on AI and the value of DePIN in enabling smaller companies and startups to innovate in AI, that's going to attract a lot of interest from non-crypto people into crypto, even if it's for the next 1 or 2 years or 3 years. And as a result of that, companies like Akash, it's going to force us to really accelerate, our roadmap and focus on things that enable non-crypto people to be able to work with Akash, right? So where if there wasn't the AI hype, maybe we would have focused on something that is very, very crypto specific. Maybe we would have focused on features that enable blockchains and others to run nodes on Akash, maybe doing things to make their life easier. Now, because we have to focus on non-crypto users, we're focused on things like providing an experience where people don't have to connect with a wallet, right? For example, that's a good use case where if you're a non-crypto user coming to Akash in a few months from now, you wouldn't have to know what a wallet is. You wouldn't have to know that there is AKT underneath that's going to be used. You'll just get an experience similar to what you get from literally any SaaS service today. Like if you go to Google or AWS, you can sign up for a free trial, you get some credits, you can try out the service, and if you like it, then you can put in your credit card information and use it, and that's basically the experience we're going to build. And so to your point, like if the AI hype dies down in 2 years, that service will still be very valuable for people that are doing generalized web services. So whether you're running an e-commerce application or you're running a static website, all of the infrastructure that we build for AI companies today is going to be useful there. And then I think the other sort of thing I can point to is, on the negative side is some of the things that I personally feel like are kind of distractions is, I hear a lot of people talk to us about, are you looking at things like restaking and stuff like that? I don't know a ton about that whole space and the things going on there, but for us, we're staying away from all that because we just want to focus on users and making sure we acquire users in both crypto as well as non-crypto that are building on AI, because that's ultimately going to force us to build solid services that are going to be used by people that are doing generalized applications later.
Yeah, cool. So I almost hear like not being too opinionated about what the infrastructure and things will be used for, but you know, using it, doing AI stuff, and then but also you know being open to other types of workloads and things that pick up. I think we're at time, so we'll just wrap up here. Thank you all three for being here, for joining me, and we'll all be around. So if folks have questions, just come grab us.